Hello, today I have for you a new library. It's called Supervision. When using this library, we will be able to write less code and achieve more. This library is a collection of a computer vision tools out of the box. It helps us on do detection on an image or a video, count detection on a certain zone, without writing a lot of code. And today I'm gonna show you some of its capability that we can do it, but not all, using it with Yolo V8 and Detectron. Before we start, I just want to tell you this library is brand new. Actually, it's have like 4 months since released, and it's like doing very well. I think in the first week it was trending on GitHub, a second trending library on GitHub. And it's backed by a decent computer vision company called Roboflow. I'm gonna leave you a link in the description for his LinkedIn and also to the channel of Roboflow so you can find more resources about it. Okay, what we're going to learn in this video. What is the capability of Supervision? How we can combine it with other libraries like Yolo V8 or Detectron. How we can do tracking on a video. How we can count objects. How we can do detection on an image or a video using Supervision. It's very straightforward and easy. How we can combine Detectron with Supervision and customize the annotation box styles. And what other ability does Supervision have that we might be able to use? So without further ado, let's just start coding. Supervision is brand new. As I said before, you can use it with multiple libraries if you want to. In this case, I'm using it with Yolo V8 because I love Yolo V8 honestly. It's brand new, it's powerful. And I'm just gonna show you a few things that we can do it in this one Google Colab, and in this second one we will be using Detectron to do detection in a video and an image and counting inside the zone. So without hesitation, I just start. Installing it is super easy. You pipe install it with any whatever library you use. Import it. You have to import open computer vision with it and get whatever model that you want from Yolo. And I'm using the Nano Yolo V8, and I have here a small image which down here it's not drawn. I got it from Google. You can get any image that you want, but make sure that this image have a detection it's already pre-trained on inside Yolo, like a car, a person, motorcycle, something very basic inside the library of Yolo. We read the image, we get the result of the image and get the detection inside this image using the detection from Ultralytics in computer vision. We will import it as SV, Supervision and as SV. Then we do something called bounding box annotation and label annotator. This two stuff is basically initializing the boxing that we want to create around our object and the label that we want to have on top of it. Here I'm doing the labels, getting the labels, because I honestly hate when I see like a detection with just a class number, no labels. I am not a robot, I am a human being. I have to understand what the name of this class. Anyway, it's straightforward, it's a loop. And detection class, I'm getting the name from the result itself. Then here in the annotated images, I do add a little stuff on top of the box annotation is the scene. We give it the scene. Here we just initialization. Here we give it what do we want to look at is the image that we have. Okay, which our image that we got over here, and what the detection on top of it. Then here we give the annotated images also a label. Another thing is a scene, the annotated image objects, and also the detection and the labels. Then we just computer vision, the Supervision will do plot image and bam, we have a result over here. I'm detecting cars. Of course, it's not perfect, but it's showing you what it can be done with it. You can do detection with it very straightforward here. Let's take it in the next step. Supervision can also work with videos straightforward and easy. I am here setting up what we're going to need is the home direction. Downloading video, I got this video from Supervision documentation. I will leave it a link in the description for all the code I used and learned from, and also my code. You can put the colors, you can put the video over here, get the video info that you have and know what the width and the height and the frame per second and how many frames inside this video. But note here, if you're going to use your own video, I would recommend it that the video will be small, because I tried to use a little bit bigger video to have 180 megabytes. It didn't, some reason did work. I didn't know why. I think it's have something to do with RAMs, or there is might be certain limitation in Google Colab. Anyway, in order to get the first frame, we need to get frame, so we can draw the zone like here, counting the traffic inside this video, and another zone here. A zone in computer vision or supervision, it's basically an area inside a video or an image that you want to track only. You don't want to track the entire image, just I want to track this area and this area. So first thing that we will going to do is get a frame so we know from this video where we're gonna draw exactly. Straightforward, get video frame generator. Like it generate a frames, like Supervision do that for us, and we go through this generator that we create. And the next here is give us the first frame ever in this video. Then here I write this image inside the frame, first frame.png, and I'm reading it. Like as you can see here, this is the image, the first frame ever in the video. Then drawing polygon. One of the coolest thing that you also can do is, this is the Roboflow tool for drawing polygons in an image. You can just click and drop over here. You can use your mouse just to draw what you want, zone here, here, and bam. Like it gives us this NumPy array. We copy it and we will put it here. And the second zone and third zone, whatever the amount of zone that you have, we can track it. Right now we have the dimensions of the zones. We know when it's end, when it start, using this Roboflow tool. The second thing, computer vision need to create this zone and understand it. So the polygon zone is a computer vision functionality. You give it the polygon dimension and the dimensions of the resolution of the videos. Like it need to know this from the video info. So it can know where the polygon exactly from the dimension of this frame. Then we create polygon zone annotator. Is the place that we going to put our customized style for the zone. Here we doing inside here a function that will loop over inside our zone that we created over here. We give it a couple of styles, like this is basic style, the color by ID, the thickness. You can do customization here, but I'm just showing you the basic stuff inside it so you can be up and running with Supervision very fast. And here I am doing a box annotator, like the boxes that will be drawn on the car that will detect. Here I'm also using color. You can customize the color however what you want. Thickness, text scale, and looping over on the range of the polygons, how many inside these polygons. Okay, now we're going to get the result. Our model that we initialize on top with the model of Yolo V8, the Nano one. The image size, we can set it to over what we want, and I'm using the detection from Ultralytics. This is how you can combine what you want with Supervision. Like Supervision have also, if I am correct, another option from Deep Spear, and here Detectron, Metactron, Roboflow, SAM, Transformer, and Yolo NAS. This is like very powerful. You can combine it with a lot of libraries out of the box. You don't have to write any code for it. Then this detection is going to help us to loop over the entire polygon object and get each one inside it. Here I'm using this mask. Actually, I got this code, all of it from the documentation. it's brand new documentation. I will say it's not like the perfect documentation yet for supervision, but like if you have been around computer vision project, you will be able to use it. Here I am doing the mask using the zone, the trigger zone, detection filter, doing the filter here that we have on the zone that we have. Do the box annotator. We always have to do box annotator for whatever scene that we have, or in case it's a scene is a frame or an image, and what is detection that we got, filtering the detection, because we have to know which are in which zone. Okay, then we load an image, like here in computer vision. I think in the some of the Google Colab that I found for supervision, the plot image wasn't yet added, so it's a little bit outdated for some, but like you can use mine. It's new. There is the code is. What if I wanted to do the same thing here, but for a video? It's straightforward also. Like you don't do a lot, you do the same thing here. You need zone annotator and the box annotator. But this time we're going to put our for loop inside a function, and this function will be passed to another function called the process a video. It's also from supervision, and the source is our video path that we have, whatever video that you want, and you name the results video. You can call it, for example, traffic.result or traffic/result.mp4, and it will give it the callback or the logic that we will process the tracking on top of it. And I got this result. Well, it's not like I didn't speed it. It have been speed by like it come like this. It's already speeded, but it counting how many cars do we have inside each zone. Like in this section we have 8, 11. This is good. Like you can track the amount of traffic and know which one have like how to say rush hour time. I think the left one have more cars, so it's basically crowded more. The right one, which seem easier to use it. I think we can use it to analyze some sort of traffic information here by knowing which road lead to each area. Okay, that's it. That's super easy. You can do with Yolo V8. It's straightforward. You can get it up and running very fast. But what if you want to use it in something more, I will say, better, like, or take it to the next step? I got here a Google Colab that using GPU. You can change the runtime type from your Google Colab by clicking change runtime type, selecting the GPU that you find, and start typing the code. I'm using the same thing here, supervision, setting the home, downloading this video. It's subway. We're tracking the subway count on the area of that might be dangerous for passenger to step on top of when the metro is coming, when the train is coming. So here is a different approach. I am going to use first our supervision with Yolo, but then I'm gonna combine it with Detectron. Detectron is a Facebook library that have the ability, a pre-trained ability that you can detect with. Here, I'm importing the same thing, give it the model that you select. You can select whatever model that you want. Get video generator, we're creating frame because you have to draw a zone, but first we have to detect. I am iterating on top of the frames. You can get any frame that you want, get the next, which is the first. Here I'm using the result detection, getting the detection from the model that we have, get the detection from Ultralytics, as I mentioned before, and I'm using label annotator as a nationalization. But in this case, I'm looping on top of the class IDs to get the names from the results. Here I'm getting the box annotator. I'm giving some style, thickness, text scale. You can make it small or big, however what you want. And a box annotator also, I'm giving it the frame or the scene that we will work with, what detection, and the labels. Here it's straightforward. You can just draw what you want with it. In our case, we're using here also the plot image from from Supervision, and it gave us the result. But as you can see, if the more I keep looking to this image, the more that I feel there is something wrong about it. Like this lady is not a teddy bear, I am pretty sure. And this is a person, yeah, this person, backpack, handbag. For some reason, it doesn't detect this guy. This is a stop sign. We need to detect this kind of stuff. So next step is to get Detectron. You can install it from GitHub itself, and you can read about it. It's a very nice library also from Facebook or Meta. I keep saying it's Facebook, the old name for the company. And we import it normally from Detectron here, and we can get the version. The current version is 0.6. This is Detectron 2, 0.6. I'm importing the library that we are using. It's Coco, which I think it's a pretty famous library if you know about it. This is why I use GPU, because you have to build the predictor for Detectron here, and then I'm starting to use it. It's doing the same thing with Yolo, but the different here, get the frame generator, the same thing that we did. Here the output is the predictor that we will use, or we build over here. We give it the image, and here we're getting the detection from the predictor that we have, which is our output. You can read about all of it, this stuff. I got it from Detectron and also from another Google collab, Supervision, I found it on GitHub. This is how you can get it and also change it to NumPy. After we did get the detection, information that we need is the XY for the image, the confidence level, the class ID. I built on top of it the labels. I needed the labels, honestly. As I told you before, I don't like to see just number. I love to see the names of this class. So I did my search and I found out you can do it. Pretty straightforward. Also, you have to use metadata catalog and Detectron and give it the dataset that we have here. Then get the classes, and I kind of print it over here, and then I passed it also to the box annotator to annotate our image, which is drawing on top of it. Here, as you can see, it's got change. The results is far better. Like this lady, he can see it as a person. There is stop sign here and bag. He can detect this guy, as I told you so. And the rest is he can detect all this person. It's have a better accuracy. Then we going to do the same thing, but for a video. We will get the video information first, so we can know the width and the height, the frames, all the stuff. Then draw a polygon. Same tools we have right now. This image, we can upload it and draw the polygon on this line over here, so we can know if people cross it. We can count how many people might be in danger in terms of is a train arrive or not. Here the polygon zone that we draw on top of computer vision is here we get from Supervision a polygon zone, as we did in the last one video. We create the box annotator for it, give it style, polygon zone, also give it some style. Here I made them place that I think is this place is red. I will show it to you now, and give it a thickness text. As you can see here, it's red because it's dangerous to cross. I also found out that Supervision doesn't have only boxes, it have also another styles. Like you can check here inside, I think it's inside API, annotator, might be right or wrong. Yeah, here in annotator you can find the different kind of styles that you can use, or annotators you can find. Like box corner, this is really cool. Look like the CSI movies. Box mask, which what I use. Circle, if you want circle to track a dot, which I think it's not very visible for us. The eclipse is technically a drawing around the bottom of this object. A halo, which it's like outer glow for the object. A mask, which is like segmentation if you think about it. A polygon, which is like also some sort of segmentation style. So there is a multiple style that you can use here. I use the box corner, the box mask, because it's very visible and powerful for the eye. So let's go back to our code. Here I did the detection using the predictor for Detectron 2. Give it the image, get the XY from it, the prediction box, confidence level, the classics ID, all the stuff. Here you can filter actually the class ID by 0, which is a person. I don't want to track anything except people, which is 0. When we trigger the zone by giving the detection, here I did the box mask annotator style that I told about. You can give it color as you want, whatever. There is different option for coloring you can find here. I think it's color. You can find it here that you have option like as BGR, there is out of the box, like, and also there is hex, there is RGB from hex, and a different kind of example. But this inside this API, you'll find it in raw. And then I did the box mask annotator, give it the frame, which is our scene and detection. You can comment this and see the result of the box annotator, not the box mask annotator style. You can give it more option like thickness, text thickness, the scale, the color. You can do a lot of stuff with it. All right. Then I annotate the zone and I give it the frame that we have. Here it doesn't count anything inside our zone, so it gives us 0. And this is our object that here is the person that we want to track. So we're doing the same thing but with a video tracking with polygon. It's the same steps, only the different thing that we are here doing the process for the frame inside a function, and we give this function to the same function that I showed you before, which is a process the video. And we give it the function that we created over here and the target base that we want, in our case, the result that we want, and the source of our scene or the video, which is here, subway video base that I created on top of up. When it's work, it will print out every frame that we get, like here, print out the frame I, which is the index of it. And then it will, after it's done, it will did give me the result over here. I had to download it. So I'm gonna show you the result over here. Yeah, as you can see here, it's not perfect because the video kind of shifted to the left a little bit, but it will start count here. Like so far it's 0. As soon as we open the door, it will start counting. Yep, it's already counting. 5, 4. Yeah, it's changing the number. 8, 7, 3, 2, 1. Like it's trying to catch as many people here. Yeah. And it's done. So that's it. That's how you can use supervision with detection. Before we end it, we must take a look at other stuff that can be done with supervision. We already did detection and annotation. We did a process video, but in the documentation it doesn't show up yet. Track object, we already did this in a video. We did filter on person. We did when we used the subway project, small project. We did already filter what we needed to track. And here we also did, but we didn't do a valuation model because we didn't build anyone. You can take a look at the API, see what you can do, classification, detection. There is annotation that we already talked about, the trackers that we have here. We also have working with data sets. We already did with the Coco data set. What is the matrix that we have for object detection over here, confusion matrix. And here that you can take a look at the different stuff that you can do in the matrix of supervision. Drawing, which already take a look at it, which is the color, I show it to you. Utils is that small helpful function that you can use like video info and plot image that we already use multiple time. And assets, which is I think doesn't work for some reason. I tried it by install supervision assets. It didn't install. I don't know what's going on honestly, but as I told you, This is a brand new library. It's just like not even a version 1 completed yet, but it's very powerful, which with what we can do, supported with a very decent company called Roboflow. I hope they succeed in making this library more powerful, and I hope also to get a cookbook, because it will help us to technically take our code and reuse it however what we want, and I see it succeed in the future. This library is very powerful, but it's still brand new. You don't have to write a lot of code using it. You can combine it with a lot of libraries, as you can see. I'm gonna leave you all this code link in the description, and I hope that you learn something new. Also, follow this library and support it on GitHub. It's brand new and it deserves the support. I hope that there is also the author, I think he said that he's working on a very big roadmap for Supervision. So I hope I see it coming soon. Thank you for watching this video. See you in the next one.